second session in this training day, and this is about developing VCL custom controls with taking high DPI and taking VCL styles in account. And actually this presentation is the result of working for a long time. I can tell you that we have spent a significant amount of time in making our VCL components high DPI ready and also VCL styles ready. It was quite a challenge. It involved like over 400 visual controls in the VCL UI pack to make these controls ready for high DPI and VCL styles. And in this presentation, we like to explain how we did that process, and so for you that you can learn from it. In an ideal scenario, you don't need to take high DPI and VCL styles in account because our components take care of it and the VCL framework itself takes care of it. But I can imagine that you have specific needs for components that are not in the standard VCL controls, that are not in our VCL UI pack, so you need some customizations here and there, and you want to make these compatible with high DPI VCL styles. That's what this session is for. Or, for example, many of our VCL components, they offer also via events little custom drawing things, customization things, and if in this code that you did at application level on top of our components you want to make them also high DPI aware and VCL styles aware, this is where you can take advantage of the content of this session. And here you see, for example, the VCL planner. There is the Kanban board, there is the VCL grid, a gauge control, the navigation control on the left side, and here you can see in a high DPI environment that this is switching between different VCL styles. So I would say this is the result of the work. Little side note, that is high DPI is also a kind of, for us at least, moving target. Because we have seen in the different iterations between the first Delphi version that supported high DPI and the latest version now 11.3, there have also been subtle differences in how the VCL framework itself deals with high DPI. And so that means that during that process we also had to adapt from time to time our code to make it compatible with all the Delphi versions that support high DPI. VCL styles was somewhat more, I would say, stable, although also there, during different Delphi versions, there have been subtle extensions to how to deal with VCL styles at code level, and our components along the way have also been adapted to that so that they are usable in every of these Delphi versions. And of course, as this is on one side the moving target, on the other side we are dealing with a huge amount of components here, there can be always some scenarios where something is not behaving as you would expect it to behave, and then of course we are there and we are standby, and if we hear about it or if we discover it ourselves during testing, of course we keep addressing it and we keep perfecting it. Here I think the words of the famous painter Salvador Dali are perfect in place. Anyone knows the quote from Salvador Dali in this respect? No? Salvador Dali's quote is, "Have no fear of perfection, you will never reach it." And I love that quote. All right, so for this presentation I actually based it on a sample control. No worries, all the content, so all the slides and all the code, all the samples from every session. In fact, you will also receive it as a download after these training days. So the code that I'm using here will be in the download distribution, so no worries about that. But as a sample control to focus our attention on for high DPI VCL styles, the control I created for that is the T accordion control. So it's not in the VCL UI pack, it's specifically developed for this session. So the accordion control is a control that consists of items. So as you can see, item 1, 2, etc. And an item with a caption and some content, some text. And so the item height can vary. We can also use different fonts for the item caption and the item content. And of course, the colors, selection color, normal state color of the items in our accordion control can change. And so, as you can see, understand, this is where we will do things with regard to high DPI and VCL styles. VCL high DPI first. So yes, this was introduced. I think the first sign that we would get high DPI on Windows was actually introduced by Apple. Anyone knows the first introduction of the concept of different DPIs to handle by software introduced by Apple? I hope everyone is awake here in this session. If it is a motivation, I have some gifts, some additional gifts for good answered questions. So the first thing Apple introduced where we had the concept to deal with screens with different DPI. I heard iPhone. Who said iPhone? Okay. I have a mug for you. It's the first edition of our mug, which still has the heart, and that was the Valentine edition. Ah, it was for you. Sorry.
Thank you.
Here you go. I want to give away all the mugs I have with me during these 2 days. Okay. Apple iPhone, that was correct, and they introduced on the iPhone the Retina screen that had a double resolution of the normal iPhone, and that's what kickstarted this whole high DPI scenario. Then Apple introduced on the Apple Mac machines also Retina screens, and now they are already at Retina 5, I believe. And so Windows couldn't stay behind, and so Windows offered also high DPIs from, I believe it was Windows 10, if I'm not wrong. And now this is, I think, about the range of high DPI situations that we can have on a Windows machine. So ranging from, well, the very old screens, 640 by 480, I think no one is using that anymore. But then we got 4K, and nowadays there are even 8K screens. And this is left, right, the difference, the result between the different DPIs. What is actually happening is that the graphics card is doing hardware anti-aliasing to make everything sharper on the screen. And this is perfectly visualized by this comparison. So how, as a Delphi developer, are we dealing with high DPI? For a long time, in the Delphi IDE itself was still the normal 100% DPI being 96 DPI, 100%. And so it was with the introduction of Delphi 11 that the IDE itself was also running in high DPI. And in addition to that, Delphi 11 introduced also that the form designer, which was before also all the time 96 DPI, that in the IDE, our form designer, we could change it, not being 96, but adapt to the screen DPI. And so it's an option. You can select it as you want it. And that was with Delphi 11 the first time. We also have the DPI per monitor support. So that is the situation where you have different monitors connected to your machine, where different monitors can have different DPIs, and that your application should dynamically switch the DPI between when you move it from one monitor to the other monitor. And so that was introduced, that support was introduced in Delphi 10.3 Rio. That was the first time when you could choose in the options for your application from the manifest that you can select, okay, make it aware of per monitor high DPI support. Is anyone from you, actually that's an interesting question for me, who is already creating your own VCL applications ready for high DPI? Okay, so that's surprising. I expected more hands. So the good thing, I always look at things in a positive way, is that you will learn a lot today. All right, so what is the foundation of supporting high DPI? Of course, it's Windows. That's the operating system where the application is running on, and it's the operating system that needs to facilitate that, for example, there are notifications being sent to your application when it switches from a monitor with a certain DPI to another monitor with another DPI. And to discover what is the DPI this monitor is having and another monitor, etc. So these are Windows APIs that are needed, necessary to make, and that the VCL framework is underlying taken advantage of to make your application high DPI aware. Actually, there is the manifest, so that's a little resource in your executable. The manifest file is what Windows will check when your application, your executable starts. And if in that manifest file there is no indication whatsoever that your application is high DPI enabled, then Windows will run that application at 96 DPI, but it will scale itself, the form, to match the DPI of the screen. And that's when you will see on these type of screens that your application, for example, if you run a 96 DPI created executable, maybe an old executable created with Delphi 7 that does not have that manifest file with indicating I'm high DPI enabled, Windows sees it, and Windows will scale that application to match if you run it on a 4K and 8K screen, and your form will look a little bit fuzzy because, yeah, it cannot do much more than scale what's on the screen. If that manifest file indicates your application is high DPI enabled, then it leaves everything at the original size as you designed it in your application, and everything will look much sharper. Actually, if you would take an old Delphi 7 executable, manipulate the executable to inject a manifest saying, okay, make it high DPI, what will actually happen when you run it on a 4K screen is that your application will look extremely small, right? It will be 1/4 on a 4K screen of the original size that it is supposed to be, okay? But it will be sharp, but it will be small, okay? But that's how Windows at API level deals with high DPI, and in that process, and that's, I think, one of the trademarks of Microsoft, to make things always backwards compatible so that old executables will still run in the best possible way, even on modern machines. Okay, but here we are going out from the assumption that we are using Delphi with high DPI support. And so now the question is, where will this have impact on when you want to create a high DPI enabled application? So these are a couple of things that you need to take in account that it will have impact on. Of course, the size of your controls. Okay, good news here is that the VCL itself, the framework, handles that for you. It will have impact on graphical elements inside controls. So imagine that you're using a button with an image or an image elsewhere, or a control with some sections with some specific height in it, etc. So these settings, these images for these controls, etc., High DPI will have an impact on it. So if we want to make everything look good, we will need to do something in that area. Of course, logical thing, font sizes. Everything that is connected to fonts, we will need to pay attention to that. Good news here is that in the VCL, the T custom control, the base class for all controls, has already a T font property, and the VCL framework already takes care of managing that font, in specifics the font height, to make it look good on different DPIs. And of course image sizes, so you will also want to take care of doing that. Imagine that you have your little company logo in the top left corner of the screen. If your company logo was a PNG file or a bitmap file, well, if you would just stretch it to accommodate a 4K screen, it will look a little bit blurry, and there are better ways to deal with that. So, first of all, control sizes. What are the difference here? What do we need to take in account, pay attention to? So, in most cases, unless you're creating the control at runtime, you drop the controls on the form, and as you drop the control on the form, you set some specific size to these controls, a width and a height. And here we have a difference between Delphi 11, latest version, and all previous Delphi versions. That is that in Delphi 11, as I explained, the form designer is High DPI aware. And so that means that if your form designer is set to match the monitor DPI, at design time, the size of your control will be right for the screen that you're using, but it might not be right for the screen of your customer, okay? But Delphi 11 takes care of that. That means you design it on your form, your screen with your DPI. It stores the width and the height in the DFM file, together with, very important, the pixels per inch of the form at design time. And so if you create your application this way, you run it on the machine of your customer that has maybe no High DPI enabled yet, then the Delphi VCL framework will take care of, okay, my form was designed on, let's say, 200% DPI. Now I'm running on a 100% screen. So let's scale, let's divide width and height by 2 to match what the customer is having. In Delphi 10 and all the versions before Delphi 11, in fact, the form designer was always at 96 DPI, so 100%. And that means that you design it for a 100% DPI screen, but Delphi was still, if you would design it for 100% and run it on a monitor that is at 150%, it would multiply all widths and heights by 1.5 at runtime when your application starts. Of course, yes, question?
Yeah. When it's decided if it's High DPI or not, is it dynamical? When I started, okay, I have an application. I started on a monitor with High DPI, and I have a second monitor, and I drag it over.
Okay, that's
dynamical, or
that's a dynamic change. So you have indeed a possible change at startup. Okay, so depending on how your application is and at what DPI it was designed and what the DPI is at startup, that can invoke a change, right? So it might be designed at 100%, and at startup it might see, okay, I'm running here on a monitor with 150%, so let's switch dynamically at that point at startup time to 150%, multiplying all width and height times 1.5. If you move your application from a 100% screen to a 150% screen, we'll see it later on in the presentation, the application gets a notification and the same dynamic adaptation of widths, heights, etc. is happening in your executable. The VCL, that's actually what the VCL framework is doing underlying. Okay, other question?
Yeah, the other way, when I have a 4K application and I downgrade it for the customer to full HD or something like that.
Okay, so the question is, if I have a 4K screen, I developed the 4K, my application for 4K. So if you want to design it for 4K, that will require that you use Delphi 11 with your form designer set to match the monitor DPI, so 4K. So you do all the design on your 4K monitor and you run it on a normal HD screen for your customer. Then the Delphi IDE will have stored in the DFM file that everything was designed at 4K, and at startup it will check, okay, what is the monitor now and what was it designed at, reading the DFM file, and based on the difference in this number it will scale everything for you. So it will scale control sizes and font sizes. That's what the VCL is already doing for you. Okay?
Do you have to set this pixel per inch property there in the...
No, that's the...
Read it automatically.
So you do not have to set the form.pixels per inch. That is a property. If you open the DFM file on Delphi 11, you will see it in the DFM file. So that's actually the technique that Delphi 11 uses to know at what DPI your form was designed and to take it in account at application launch to compare it with the monitor DPI at that time. Okay, but you do not have to set it. The only thing that you can do in Delphi 11 is switch in what DPI your form designer will be set. Okay, so you can set it to 96, the original, like for compatibility with Delphi 10 and all the versions before, or you can say, okay, make it automatically adapt to my monitor, my development monitor, where you are using Delphi on. Important note here is for teams. If people are working in a team on the same application, and in the team there are different monitors with different DPIs. So one developer opens your application on a 4K screen, and the other developer is less fortunate and has an HD monitor. That causes headaches. So I think the best advice, if you are in a team developing on different DPI monitors, is to set everything at the same DPI. So it might not match for certain developers the DPI, but at least everything will stay consistent. Otherwise, every time you open forms, it might have an impact on this particular pixels per inch property.
Same with landscape and portrait mode of the monitors?
That specific setting has no impact on how the rendering is happening, etc., or the pixels per inch, these kind of things. So that has no impact. It's really the DPI that has an impact. Okay? Runtime created controls. So, okay, here we are not using the form designer, but we are in code creating controls, and when we create controls in code, it is kind of expected that we will also set the size of these controls. And so here the bad news is you cannot use fixed dimensions for setting control sizes because it will need to adapt to the specific situation of the monitor where the executable is running on. So advice here is, if you create runtime controls, use code that will automatically adapt what you create in runtime to the screen where it is running on. So here in this case, I want to create a panel with a width 100, height 100, and I want to make that panel appear the same size on every monitor. That's a possible code that I can use to dynamically adapt it in this case. I'm not sure how many of you use runtime created controls versus design time runtime created controls. I see like or a mix, even a mix between these scenarios. So it's certainly something to pay attention to. It also has, of course, now we talk about the control size itself, but inside controls there can also be all sorts of elements with different sizes. And the same problems apply to these different sizes within controls. So take, for example, a panel with a caption. That caption can have some specific height. Let's say in the 96 scenario, for years we set it to 20 to look good. Now, if that caption height property, we will need to do something specific to make it look good on every monitor. And of course, this is not something the VCL framework can assist you with, because there is no way the VCL framework can know that a specific integer property has a connection with some visual dimension in the control, right? So it's something that will need to be handled either by the component, or if you do things at runtime, at application level code. So perfect example here is a string grid where you have columns with certain column widths. And of course, you want the columns to look equally on different DPIs. If you set column widths at runtime, also here you will need to calculate the proper width to look good on the screen with some specific DPI. And then we come to fonts. As I explained, the T custom control already has the font property, and the VCL framework knows, okay, this is the font for the component, and the VCL framework manages the changes in font height depending on the screen where you are running the application on. Same is if you run this, if you develop your application in Delphi 11 and you run it on a 4K screen and you drop, let's say, a label on the form, then your label height, the font height of that label, will be way higher than you would use Delphi 11 and on let's say a 96 DPI screen, and that label height, font height, was typically -11. I'm not sure if that number is as familiar to you as for me, but the standard font height for a label on a 96 DPI is -11. If you use it on a 150% DPI screen, Delphi 11, it will initialize this font for you at the font height of -18. Okay, so that is what the VCL framework does for you. So that's good. Nothing to pay extra attention to in this area. But of course, components can have different font properties for different sub-elements within that control. Again, back to that example of a panel with a caption, you might want to introduce a different font for your caption and for your just the normal text of that panel. And same as with any integer property that controls dimensions, is the same for fonts. The VCL will not scan the entire tree of properties to see if there are fonts inside, and the VCL will not deal with any font sizes except the font, the main font property for your control. And so, same here, in both a runtime scenario or where there are font properties that are not the font that is already standard there at the custom control level, also there you might have to write code at application level to adapt to the font to these specific scenarios. Third thing is everything that concerns images. Also there, attention is needed. As I explained, PNG, bitmap, GIF, JPEG are all fixed size images. And that means if you use one image, for example, the company logo, if you just use one image, it will scale. And the scaling might introduce blurry images, okay? So that's actually the best the VCL can do for you. In starting from Delphi 10.3, they have introduced the virtual image list. And that is actually an image list that can hold multiple sizes of images for each of the images in your image list. Okay, so think about the original image list. Okay, we typically added like 16 by 16 icons for buttons, for example. The virtual image list allows you to create a whole series of 16 by 16 images, but also 24 by 24 images, 32 by 32 images, maybe 64 by 64, etc., etc. And when you use a virtual image list in connection with your control, the VCL framework will actually send the best matching images to your control. Okay, so it takes the DPI in account and sends the best possible image to your control. But still, you have to do the work to have a series of 16 by 16 images, 24 by 24, etc., etc. So it still is quite a bit of work. So this is actually the image collection that you connect to the virtual image list, and where you can see the different sizes of the PNGs, here in this case, for different DPIs. There is some, okay, that's not here, but there is some good news, some additional good news is that we have developed, and that's part of the VCL UI pack, support for SVG. So these are vector images, and with one SVG image, it will render as a vector, perfect, independent of the DPI where you are using it. So first of all, SVG support for, if your company logo, you have it in an SVG, it will look sharp everywhere. What we also have is the SVG image collection, and that means that with a set of SVG icons for your buttons, for example, it can automatically generate the 16 by 16, 32 by 32, whatever size. It will automatically generate sharp, starting from 16 by 16, 32. Yes, question?
How's the speed from the rendering SVG to the controls?
Okay, so the question is, what's the speed of SVG rendering versus, let's say, T-bitmap rendering or PNG rendering? Well, the answer here is there is not a single answer to that, because SVGs can start from being extremely simple to being extremely complex. So SVG support, for example, radial gradients, and can have a really set of complex instructions to render that image, and these will be slower than rendering a PNG. If it's an SVG with your company logo, for example, and that has just a few lines and squares and whatever, that is fast. Okay, so here really the point is how complex is your SVG. In addition, I would also remark that it also, I've seen it highly depend on the tool that produces the SVG. There are some SVG editors that produce good SVG code, but I've also seen some SVG editors producing really, it's kind of hard to name names, but it starts with an A, and they produce SVGs that are insanely complex for how they should render. Okay, so I would say, as a general recommendation, some attention is needed. If, for example, if for all you have a toolbar with 60 buttons, can be a realistic scenario, and if you would select an SVG set that consists of all these very complex radial gradients, all kinds of font techniques, etc., etc., times 60 for all your buttons, then you can get in a scenario where you see, okay, poof, my toolbar renders, instead of bang, the toolbar renders. Okay, so some attention is needed when using SVG. A quick check is what's the size of the SVG. So these bloated SVGs can go up to, I've seen SVGs 4K, 20K of instructions, so that's already complex and something to deal with. Okay, so the question was already there, what happens when my application moves from, let's say, an HD monitor to a 4K monitor? Of course, adaptation needs to happen in this scenario, and so what is actually happening under the hood is that Windows will send a notification to your executable, and the VCL framework uses or introduces a virtual change scale method. So if you descend from T custom control, you will also always see in the protected section of that control the virtual change scale method. So the thing to do is override that change scale method. That's the method that will be called when you move your application from a monitor with DPI 100 to DPI 200. That's also the call that will happen when you created your Delphi 11 application on a 4K screen, and it is started on your customer screen running on HD. Also then the change scale method will be called to notify your component, do whatever is needed to make your control look good on the DPI that we are running on now. So this is well, there was a variation. So from version 10.1, this change scale method included an additional parameter, but that is the change scale method in the protected section of your components. Another thing is also needed when you are making your application high DPI aware, that is, how are we now getting the definitive DPI where my application is running on, the monitor it's running on. And here I present some code. This is what you can use from Delphi 10.1, because the VCL framework offers extra properties to discover the DPI. And so this code take advantage of. Basically what we do is, okay, get the form where my component is on and ask the form what is the pixels per inch of this particular form. And the DPI scale is here is a single, that is the multiplication factor that we are needing to adapt fonts, image sizes, etc. In older versions of Delphi, where you can still, of course, use high DPI, it was somewhat more complex because form.pixels per inch didn't exist in these older versions. And then you can use Windows API functions to get the scale factor. So we are using the canvas of the control here and getting the get device caps Windows API method and do the proper divisions based on the number of pixels per inch and get the scale factor from there. So now let's go to the code and let's inspect how everything we learned so far is handled in the little example T accordion control that I created. So we are here in the Delphi IDE, and this is the source code of this little example control. So what do we have? We basically have the accordion control. Here is the control, and it just has a collection of items. And when we look at what is in an item, this is the collection item. So what we have is, okay, we have some text in the item, we have some caption with its text, and we have a Boolean property that controls whether that item is expanded or not. And then we also have the concept of a panel, and with that panel we configure what will be our caption color, caption height, what will be the font of that item, etc. You can put an item in selected state or not selected state, so we need a color for that, and that is available for customization. So let's just look. This control is created at runtime. So in my sample application, I can create this control. So if I look at the code to create that control, so what I do here is, okay, I create an instance of that control, I set the parent to the form, and then I set the width and the height of my control. Here I'm already taking the DPI in account for the size of my control, and I also hard code here at runtime the font that is used for the caption of the item, and I already insert 2 items, so with some caption text and some regular text. So I create it. When I click it, it will expand and collapse, and I can fill it, so that's a simple loop, and then my control is filled with 10 items. This is actually the code here that will insert 10 items, and it will set the font somewhat higher and the item height also to a fixed height. So let's run this application, create the accordion, fill the accordion. Now my screen here is at 96 DPI. Okay, so let's have a look at my application, and I will now go to display settings, and I will actually change it here to 150%. And let's have a look at the effect. And so that's the result we get on 150%, which is not really the result we expected. So what we see here is that the item height is still 50 pixels, but it looks awful on 150%. So let's have a look now at what we need to do to make it also look good on 150%. Back in our IDE, it takes some time to catch up with the DPI change. Okay, I'm not sure. Okay. Okay, it caught up. Good. So now I have the second project. I will open the second project. Same thing. And here I have the High DPI enabled version of my control. So what has been done? First of all, you can see that I introduced the change scale override. Okay, and the code is made so that it is compatible with older versions of Delphi as well. And so I go to change scale, the implementation. So what I did here is the following. I get from here the scaling factor that I need, which I make a private property in my control. I adapt the custom font that I introduced to set the font for the caption of my item. And so I need to adapt it here in code to multiply it with the M and D. So with these numbers, this is the change in DPI that is passed as parameter, and that will update the height of my custom font that I added. The regular font I don't need to do because the VCL framework takes care of that. Finally, what I'm also doing from here is recalculate the height of my items. So these items will take care of the font sizes, and so I do this, I force this recalculation. So what you can see here is that for all items I multiply the height of the items times the scaling factor, the F DPI scale. Of course, only if it's expanded, otherwise I do not have to take the item height in account. So when I run this application now, okay, so everything looks the same because it is running at 96 DPI, and now I'm going to change again the DPI scale to 150%, like this, and you can see that everything is still properly readable here on 150%, the height adapted, font size adapted to match the other font sizes here on 150%. As a little side thing, I also create a label here at runtime, so you can see that the label has the same font size as the label that is already on the screen. And actually, let's have a look at the code for that. So here you can see that to position the label at the right position, I need to take the DPI in account. It's runtime creation after all. And also, as it is runtime creation, I need to adapt the font to make it really the -18 font that I want it to be on the form, regardless of the DPI. So when I switch it back to 100%, and I give the IDE some time to recover from that situation, it needs quite a bit of time. But eventually it should get there. Okay, here we are, and so now when I create that label, it looks good, and the same vertical position that is correct here in this scenario. So with these steps, we have already made our application high DPI aware. So let's have a look now at VCL styles. So what's our situation with VCL styles? This was introduced in Delphi XC2. Yes, question?
Yeah, may I ask about why we talking about height, not width of console? Do we have to take care of width of console?
As far as I've seen so far, the DPI effect is always the same, both in the width and height direction. So with one scale factor, that is sufficient. Okay, for the label, if that was your question, why we don't change the label width? Because the label is set to auto size. Okay, if that was not the case, you're fully correct. I would also have needed to adapt the label.width. Okay, so VCL styles. Just quick question: who's using VCL styles? Okay, good. So introduced in Delphi XC2, And then some additional work was done around Delphi XC6. And we have also seen continuous improvement underlying in the VCL framework to deal with VCL styles. And basically, what is VCL styles? It is resources that are bundled with your application. And the VCL rendering is using these image resources to render parts of your control in some particular style. There are already a range of VCL styles included in Delphi itself. So you can find them under the application options under appearance. There are also additional styles in Getit available. So simply start Getit, search for styles, and download them, and they become automatically available in your IDE. And there are also third-party styles. If that's not enough what is in there, you can purchase still additional styles. How do we deal? So normally, if you use standard VCL controls, if you use VCL UiPath controls, you don't need to deal with it because the controls have built-in support. But if you want to get your hands dirty doing VCL control development yourself and make them VCL style aware, the API for that is in the VCL Teams unit. And so basically you can, for each control and each part of a control in different states of that part of the control, retrieve how that part in that state should be rendered to match the style that is selected in your application. And so the APIs available for that are offered via the style services, the interface that is the access to all these functions. And one of the basics there is to get details of an element. So an element is a part of a control in a specific state. And so here, for example, I'm getting the details of how a themed grid, so a VCL style aware grid, draws or need to draw the cell in normal appearance. Okay, I can ask the same for a themed button, a themed combo box, checkbox, and the list is very long of different controls. I can also ask it for the TG cell fixed, for example, for a fixed cell in a grid. And so here is some piece of code that, first of all, asks from the API the details how to draw a specific part of a control, and then actually performs the drawing through the style services interface, the draw element method that draws on a canvas, and it draws with the details parameter in a certain rectangle. And that's actually, these are the basics to get something done from the VCL styles. And here you can see when I execute that code for different styles for same elements from controls on the form. The first thing was, okay, how do I get, for example, how is a checkbox drawn with some specific VCL style? How is a fixed cell drawn in a grid? But I can do more. I can also give me please color information. How should the color be of a caption, for example, in my current selected active VCL style? And that's how you can do it with the style services interface, get style color, and then you specify what exact parts of do I want to get the color from. And here you can see a piece of code that extracts it for different elements and draws some rectangle in some specific color. And here the same is happening with the get element color, where you get it, for example, give me the text color in a normal grid cell, or give me the border color of a normal grid cell. So all these colors you can also query via the style services interface in the VCL.Teams unit. And then there is something also you need to take in account, and that's a little bit same as you would handle the DPI change, you also might need to handle a VCL style change. If you enable your application to select from different styles at runtime, or you might have a style that is light colored and a dark colored style and automatically adapt to your operating system, then is when you handle the custom message style changed event. And so that method is called when you dynamically change the style at runtime in your application. And basically from there you might need to initialize certain things in your application. So here we deal, for example, we update a color property of a control when at application level the style has been changed. So and there is, the final thing is something extra introduced in Delphi XC6 that is, normally you would expect, okay, I've chosen for VCL style, so I want all controls to be consistently drawn with the VCL style I've chosen. But if you want to deviate from that, in XC6 the style elements property was introduced at the custom control level, and that allows you to turn off. So regardless of the VCL themes, it will stick to the property that you have used for the font, for the color, for the border. And so this is an extra property to control these things. And we have added this support for VCL styles in our accordion control example here. And so let's go to our IDE and select the project that has this VCL styles support. So here is the code of our control. Obviously VCL themes has been added. In the control itself, here the CM style changed method was added to be notified. And let's have a look at, when I look at style service, here you can see that's the initialization of the style where I change some color properties, but there are other places. Here is where the control is painted. And you can see here, this is the loop for all the items to be painted. And here you can see that if I'm using styles, then I'm getting the style setting for a fixed grid cell and some color settings, and then I draw it with this style details that I fetched from the VCL style chosen. So that's not the right application, that's still the old one. I need to activate it, of course, activate this application and then run it. So here we are. So here we have a dark colored style, and if we create the accordion, it looks like that. If we fill it, it looks like that, and you can see that if I select it, it has a selection that is similar to cells in the grid that are selected. And as you can see, here I'm changing the style at runtime. You can see that my control nicely changes with the chosen style. So that's what was needed to make my control VCL style aware. And so that brings us to maybe a few last questions if there are. If not, then we try to do the quick room switch. No more questions on VCL styles? Yes?
For the TMS FNC controls,
yes.
Does the same situation apply to the...
At this moment, this implementation for VCL styles is what we did for the VCL UI pack. Okay? For FNC, these we have not yet made VCL style aware. We have introduced for FNC controls built-in Windows light dark, Office light dark styles. So that's yet another way to do styles. with the focus on make it look similar to Windows, make it look similar to Office-based applications, which actually you could already do for years with VCL controls as well. Okay, but in FNC, it's at that level that we have supported it. All right, I propose those who want to go to the other session to take the elevator to the second room, floor 2. Ouch, it's robust. So thank you for your attention, and in this room we have our colleague Wagner now.